Welcome to the Explainer. For about the last 50 years or so, we've lived with a really clean separation, right? You've got the digital world, that's software, code, all the abstract stuff. And then you've got the physical world, hardware, chips, the things you can actually touch. But what if that whole idea was just a temporary phase? What if code is about to become reality? This is what we're calling the physical revolution. We've always used this metaphor: the mind is like software, and the body, or the brain, is the hardware it runs on. It's a neat analogy, but what if it's just wrong? What if that line we've drawn between the two is about to blur and then just disappear completely? What if computation stops being something we do to the physical world, and instead it becomes something the physical world just is? You see, we're right in the middle of this fundamental shift. We're moving away from writing abstract code that runs on separate, dumb hardware and into a whole new era of physical computation. And this isn't just one single technology. It's a huge, sweeping trend that's actually unfolding in three really distinct and pretty fascinating ways. So first up, let's look at how code is literally physically building the world around us. And I don't mean through some big corporate plan from a central office. No, this is happening from the ground up, orchestrated by code on decentralized networks. This is all happening through something called DePIN. That stands for Decentralized Physical Infrastructure Networks. Now, the concept here is actually pretty simple, but it's revolutionary. You use crypto tokens as a reward to get a global community of people to build and operate actual tangible things. We're talking wireless networks, fleets of GPUs, even energy grids. So how does this actually work in practice? Well, it's this really elegant and powerful loop. First, as you can see, you contribute some kind of physical resource. Maybe it's some extra GPU power you're not using or your internet bandwidth. Then, the blockchain network verifies your contribution using what are called smart contracts. You can just think of those as automated, totally transparent agreements. And finally, this is the magic part. You earn crypto tokens as a reward for participating. It creates this amazing, self-sustaining system for building real-world infrastructure. And just so you know, this isn't some tiny niche idea cooked up in a garage somewhere. As of early 2024, the DePIN market was already valued at over $16 billion. That's a huge number. And it tells you that there is massive and rapidly growing interest in using these digital incentives to build real physical stuff. And what's really cool is just the sheer variety of things being built. I mean, look at this. We're talking about global wireless networks for IoT devices with Helium, a decentralized network of GPUs for heavy-duty rendering with Render, and even projects like Grass that let you monetize your spare internet bandwidth. In every single one of these cases, code is the blueprint that's directly building a physical service. Okay, so code can build these huge public infrastructure projects. Got it. But this physical revolution is also getting really personal. It's changing the very way we think about our identity by grounding our digital selves in things we can physically hold and control. I mean, think about it. For decades, our digital lives have been controlled by these massive, centralized companies. You know the drill. Every time you hear about another giant data breach or a platform suspends someone's account with no warning and no appeal, we get a painful reminder of the risks. The truth is, we don't really own our digital identities. We're just renting them. Now, that sign in with Google button is super convenient. We all use it. But it's still a model where a central gatekeeper holds all the keys to your kingdom. The new idea, the new paradigm, is called self-sovereign identity, or SSI. And the idea is beautifully simple. You hold your own identity credentials in a digital wallet that you physically control, probably right there on your phone. And the technology that makes this whole thing possible is something called verifiable credentials. The best way to think about it is like a digital version of your driver's license. But this one is cryptographically signed, which basically means it's digitally sealed so nobody can tamper with it. A trusted source, like the DMV, issues it to you, but you are the one who holds it and you decide who gets to see what's on. So the crucial point here is the flow of control. It's a total game changer. Imagine a university issues you a digital diploma. It goes directly into your wallet, not theirs. Then, when a job application asks for proof of your degree, you can present just that single piece of proof and nothing else. Think about it. You could prove you're over 21 without ever revealing your actual birth date, or prove you have a license without showing your home address. You are in control of your data. All right, so we've seen how code can build the physical world around us and how we can physically control our digital identity. But this third step in the revolution, this is the most profound. This is where the physical material itself becomes the computer. It's where intelligence stops being just an abstract algorithm. This quote right here just brilliantly captures the core idea. For decades, we've had it in our heads, mind is software, brain is hardware. But a new theory called biological computationalism argues that this is fundamentally wrong. In a real brain, you can't separate the algorithm from the physical stuff it's made of. The wet, messy, energy-hungry biology is the computation. And this chart does a great job of clarifying the difference. In the computers we use every day, software and hardware are totally separate things. But in this biological model, they're inseparable. The substrate is the algorithm. Our computers deal with abstract logic, but biological computing is this messy, beautiful mix of digital and analog signals, all grounded in the real-world problems of, finding energy and staying alive. And we are rapidly building machines that actually embody this principle. This is called neuromorphic hardware. These chips aren't designed to just run software better. Their physical architecture is the computation. And just look at the acceleration on this timeline. We went from simulating 1 billion neurons in 2018, and then just 6 years later, Intel's Hollow-Point system has the neuron capacity of an owl's brain. The pace is just incredible.
So, this all leads us to the almost unbelievable conclusion of this trend. We're moving beyond hardware that's just inspired by the brain to computers that use the brain's actual, literal building blocks. We are on the verge of building living computers.
Okay, get ready for this. Recently, an Australian company called Cortical Labs launched a product called the CL1. And this is the world's first commercial synthetic biological intelligence. What does that mean? It's a computer that literally runs on living human brain cells that are grown on top of a silicon chip. This is not science fiction. This is a real product that you can buy. So how on earth does something like this even work? Well, lab-grown human neurons are put onto an electrode array, and they naturally start to form their own connections, creating this living, evolving neural network. And the way it learns is fascinating. The neurons inherently seek out predictable, low-energy signals, and they try to avoid random, chaotic ones. It's a built-in reward system. And the efficiency is just staggering. A human brain runs on about 20 watts of power. That's enough for a dim light bulb. The energy savings are almost unbelievable. Okay, let's just step back for a second and tie all three of these incredible trends together. Because DeepIn and self-sovereign identity and these new biological computers, they might seem totally unrelated, but they are all part of the same single fundamental shift. It's a move away from the world of pure abstract code and a return to the physical. With DeepIn, digital tokens are used to build physical networks. With SSI, our very identity is grounded in cryptographic proofs that we physically hold. And with biological computing, intelligence is no longer just some abstract software. It's an inherent property of a physical system. That old separation between mind and body, between code and reality, it's dissolving right before our eyes. And this leaves us with a pretty profound question, doesn't it? We are entering an era where that boundary between the digital and the physical is collapsing. So when code can build our world, when our identity is something we literally hold in our hands, and when intelligence itself becomes a property of matter, the possibilities are just endless. The only real question left is, what kind of world are we going to build with it?